This is MAT170 Module 1. We're going to take a look at our introduction to functions. So the basics of functions and their graphs, that's what we're looking at first. First, before we talk about functions, we need to understand what is a relation in math. So it's kind of a circular definition, but a relation is the relationship between two or more sets of values. And what we will typically be working with is just two sets. We'll define one as the x, which is our input variable, y is our output variable. And the relationship could be various things, but it's typically set up by some sort of mathematical rule of how one value gets mapped to another. So we might have the numbers 1, 2, 3, and the output values could be anything, 76, 24, 3. And there's some kind of a rule that will match each input to an output, and sometimes we could have more than one, but any kind of setup like this is a relation. So the definition of a function starts with a relation. It is a relation, so it's going from one set to another set by following some rule, but it has a special constraint. Each input value can be mapped to exactly one output value. So that's what a function is. We're going to see what that does. Relation doesn't have to follow that rule in general, and there's a lot of things that are relations that we will not be studying in this class because this class is about studying functions. So what we're going to look at is that each input will have exactly one output. So here's an example of a function. Again, we have an x and y. We can list it as a table of values as we do here. We can do it in more of a visual display of showing the input values getting mapped to some output values following some kind of rule. And sometimes those rules are just random, that 4 goes to 5 because 4 goes to 5. That's the rule. 0 goes to 5 because 0 goes to 5. So this is a function. Each individual input value gets only one pathway, one mapping to the output function. That's the only thing that matters. It is okay that the output of 5 is shared by two inputs. It's just that there is a one directional arrow from each of the inputs, only one of them. Okay, and so that what goes along with functions is we call the x, the input variables, input values, that we refer to with the name of domain. So it's the listing of all the numbers that are in the input values. So you see those listed here. The range is going to be all output values or y values as we got here. And notice even though 5 gets used twice, it's listed in the range only one time. Okay, so domain range, functions. So another kind of, it's always helpful to understand what something is, what doesn't make a function. So we're going to look at what's not a function to help us understand what a function really is. So here's an example, and what we see, there is one part of this, that there's an input of -4 that has two pathways, two mappings to the y values. Okay, that makes this not a function. It has violated the rule of one input going to one output. One input, each input having only one output. Okay, so that rules have been violated. It's not a function. And what we can see here is that when we plot all of these, most of these points are okay. If we look at the input of 6, it's going to 11. And let's just kind of draw a vertical line there. It's only going to go through that input once. Here's another one. It's that input, these vertical lines are saying, okay, the input of 7, how many outputs are there? But when we come to the output of -4, notice we get two outputs for that input. -4 is the input, We've got two outputs. That's not a function. So what we're going to do is we're going to build on this and come up with a rule, a visual way of telling whether something's not a function or not. So there's this thing called the vertical line test. If we look at the graph of a function, we can tell whether or not it's a function if there are no vertical lines that intersect the graph at more than one point. Then it will be a function. Okay, so, but if it touches it in more than one place, it's not a function. So that's what our last one did is here's our vertical line. It touches the graph in two places, not a function. So let me go back to here. And, you know, it just takes one bad apple to spoil the whole bunch. Okay, so just this one place. If we took one of these points out, we could have a function, but with those in there, it is not a function. Okay. Well, what if they don't give us a graph, but they give us an equation? So I'm going to show you two ways we can approach this. One way is we will take the equation and solve it for y. So let's go ahead. We would, in this case, x squared plus y squared equals 9. Let's subtract x squared from both sides. And so we're going to get that y squared equals 9 minus x squared. We haven't quite solved for y yet, so what we're going to do now is if we take the square root of both sides, we will get just y. But when we take the square root of both sides, we have to remember that that introduces both a plus and a minus because we get two answers. So because when you're squaring, notice if you put in -3 for y, you get +9, and if you put in +3, you get +9. So we have this two answers, and so really what there is that there are two outputs here, right, for exactly the same input of the x value. So there's a y1 value, which is positive for this same x, and we could call this x1, whatever, or just x. And then we get a second output, which is going to be the negative version for exactly the same input. Okay, so we get two answers. So we could see that that's not going to be a function. Each input actually has potentially two. And let's take a look what that looks like graphically. Now, most of your graphing calculators, if you wanted to graph this, you actually have to graph this as two separate functions. But using Desmos, which we're going to use throughout this course, allows us to see that, let's pull up our x squared is going to allow us to see why it's not a function. Plus y squared equals 9. And what is that graph? It is a graph of a circle with radius 3. Square root of 9 is 3, and so that's why we've got that. And again, we can come back here and we see when we draw vertical lines in any particular places that they're touching in two places. Now there's one place if we could do the tangent here that would only touch in one, but again, it only takes one place where it touches in two places. Come back here. Sorry. So we've got points here. So that's violated it. This one violates it. This is not a function. Okay, so another way is graphically. You can look at that. Next, let's look at if we've got a function, and most, again, but there'll be some questions asking whether it's a function or not, but then once we start into this, we're always going to be working with functions in this course. So we're going to determine how to do that. So we need to evaluate a function. So we've got an input. Our input value in this first case is x equals -5, and we want to put it into this function. So the x goes into this part of the function. So the first step is to rewrite it out as f of -5. And when I'm going to rewrite this equation, what I'm going to rewrite is that x, I'm going to replace it with a new symbol just a big open parentheses, because that's a nice place to put an input. So then so we get 2 big parentheses, so that's 2x squared minus 6x, and notice I'm just writing a different symbol for x. And then what we do is whatever's into this parentheses, that's the input, that goes into each of these input spaces for x. But notice if I had actually written the x, it's hard to plug stuff in for x because it's taking up space. Okay. And so then we do the math, the arithmetic. Negative 5 squared is 25. 5 times 2 is 50. Negative 6 times negative 5 is a positive 30, and then plus 3. So our final answer is going to be 83. So we could say that f of minus 5 equals 83. So we've got the input and the output here. We could write it as an ordered pair. Here's our x, here's our y, and there we go. Now, what if we have x equal to something that has a variable in it itself? So x equals x plus 1. Again, we do like we did with the last one. We're going to set this up, but this time we're going to put a little bit bigger space in that parenthesis. So it's 2x squared minus 6x plus 3. And then what goes in here? Well, tx is t plus 1. So everywhere you see this big open space, we're going to put in our t plus 1. And now we need to do the math. One of the things we notice is this first one, it's squared, so we have to FOIL out t plus 1. Okay, maybe on our scratch work somewhere, we'll come over here. It's really t plus 1 times t plus 1, right? And we're going to need to FOIL that out. So that's going to give us t times t is t squared. We get t times 1. I guess we'll do it here. So we get 1t plus 1t, right? And then we get 1 times t, so we get another 1t. And then we get 1 times 1, which is 1. So this becomes t squared, combining like terms, 2t in the middle. A lot of times that gets missed. People will take this 2 and distribute and make this t squared plus 1, sort of by distributing that power, but that's not how it works. This squared is saying t plus 1 times t plus 1. Now we're going to be okay. This 6, though, does just distribute. So we get negative 6 times t, negative 6t minus 6, okay, plus 3. And we're almost ready to go. We just need to distribute this 2 through. So we get 2t squared plus 4t plus 2. Then minus 6t minus 6 plus 3. And then combine like terms. So let's kind of change color so it's a little easier. So there's only 1 t squared, so 2t squared. That's fine. There's a 4t and a minus 6t, and that's all the t's, so that's going to give us a negative 2t. And then there's a plus 2, a minus 6, that's going to give us a negative 4 plus 3. So negative 4 plus 3, that's going to give us a negative 1. And that would be our final answer there. One more example, and again, you'll see these in the notes, is this variable that is just x. So x is becoming x divided by 4. It's kind of like, how can I put x in for x? And again, that becomes difficult if you leave that x in there, but if you just replace the function by a big open parentheses, x is now just a big open parentheses, so f of x equals 2x squared, minus 6x plus 3. And then we're going to fill in with what? Well, this is what x is. It's x plus, or x divided by 4. Okay, and so now we go ahead and do the arithmetic part. We square this, so this is going to be x squared. Now, when you've got a division, a fraction, when you square it, it's x times x over 4 times x over 4, so you can just square the top and square the bottom. So that's x squared over 16. And then we get 6, and we'll multiply the top minus 6x over 4 plus 3. And then we just need to reduce the fractions. So 2 goes into 16 8 times. This is going to be x squared over 8. And 6 and 4 reduce because 2 can go into both of them. That gives us 3x over 2 plus 3. So that would be the answer for that part. Okay. So evaluating functions. Now, we're going to take a look. We're going to use this sort of same tool, but we're going to look at how do we evaluate a piecewise function, because these do come up from time to time, especially as we move towards calculus. So first thing we want to notice in here is that when we've got this function, it's a single function, f of x, it has 3 pieces. Here's the first, the second, and the third piece. Each of the pieces have 2 parts. There's a part that tells you the domain of the piece, and there's the part here that tells you the output. And you want to think of each of these outputs, they're really y equals, so y equals 2. So whenever x is less than or equal to -1, the answer, the output, the y value will always just be 2. Again, no calculation to make. Down here, y would be equal to this function. Again, they're all functions, but the output, I have to plug in the x, do some arithmetic, and then I'll get it. And this last part, y equals -1. So we've been asked to evaluate 3 separate values, and we'll go ahead and do all of those. Okay. So first of all, f of -3. What do we do first? Well, we first have to check what part of the domain is -3 in. So this is really saying x is equal to -3. I check if x is -3, is that less than or equal to -1? Yes. So this is the part that I'm going to use. If x is -3, this is telling me the output, the y value is going to be 2. There's our answer. We're done. Nothing more to do. If f is -1, then I do exactly the same thing. I find, well, if x equals -1, then which domain do I use? Well, I don't use the second one, right? Because this is -1. X is actually greater than -1, not equal to. If it's equal to, I have to use this part here. Okay, so I'm going to, again, for this one, I'm also using number 1. The answer, the output, is equal to 2. Finally, I come to the last one, f of 0. And again, I look at the x value being 0, which domain? Well, I don't use the first one anymore because 0 is not less than or equal to -1. But here, -1, 0 is right in the middle. This is a true statement now. So for this one, I use number 2. Okay, and so for doing that, I need to plug this in. So I need to put in 0 for this statement. So I'm going to get -0 plus 1 squared plus 1. So 0 plus 1 is 1. 1 squared is 1. And then there's this negative on the outside. So that's -1 plus 1. Well, that equals 0. Okay. So notice how I got my y, my output value by going through that. Now we didn't have anything that was x greater than 2, but yeah, if you had wanted to find f of 5, you'd say, well, 5 is greater than 2, so that I'm going to use this part. The answer is -1. Okay, so that's how a piecewise function works. If we're given a graph, we are oftentimes asked many different questions. One question is, what is the domain? Let's use this color. What is the domain of the function? So we're looking for kind of, if we were to put it down on the x-axis, what are all the x values? Well, we can see that this graph goes from x equals negative 2 to 4. And so, yeah, we'll go ahead with blue. Now, is the negative 2 included? Well, it doesn't show a solid dot or an open dot, right? Open dot would mean it's not. A solid dot would mean it is. Well, if it's not open, we assume it's closed. So this domain is going to be a bracket -2 to 4. You can also write this as negative 2 is less than or equal to x, which is less than or equal to 4. So another way um, to write the domain. What is the range of this function? Well, for that one, we're going to be looking for the y values. And let's see, what do we use that one? So let's use a different color. So we're looking from the bottom of the graph, in this case all the way to the top. It stops there at 3. So the y values go from negative 2 to positive 3. And again, since there's no open dots, we assume that they're solid, that they're included. So we're going from the lower value of negative 2. And again, notice this is a y value of negative 2, not this x value. And it goes all the way to 3. Okay, so negative 2 is less than or equal to y, which is less than or equal to 3. Sometimes I like the inequality notation because it's a lot easier to spot which one is the range, which one is the domain. But a lot of times we are asked to use interval notation. So we'll keep working through that. What are the x and y intercepts? So that's another issue that we want to talk about. And so where does the graph intersect the x-intercept, or the x-axis? Well, here's a point here. Now literally it is the point. X is 1, y is 0. So the x-intercept is the point 1, 0. So notice when we have an x-intercept, it's the y that's 0. When we have a y-intercept, which is this one here, the x is 0, the y is 1 in this case. 0, 1. Now we're asked to evaluate this function at x equals 3. How do we do that? There's no place to plug the 3, but what we do is we go to where x equals 3. We take a little stroll, either up or down, whichever way we need to go, until we hit the graph. And then from this graph, we read the output. So we're kind of going down to the graph, and we get over here, and the output is going to be negative 2. So we could say f of 3 equals negative 2. So the point 3, negative 2 is on the graph. That's really what we're looking at. Now, the opposite works when we're given the output value, the y value, and then we're asked to find what is the input value. So for this one, let's see, what color haven't we quite used? Let's go with green. We're looking when y is negative 1, which is, actually, let's go ahead and put in a line. Here's 1. Pretty close. And what we're going to find here is that there's actually 2 places, where we get this intersection. So when y is negative 1, there's actually 2 outputs. This is still a function. This is okay. Each of these inputs only have 1 output. Notice it passes the vertical line rule. This is just not a one-to-one function, as we're going to learn more about that later. But what we would say is x equals 2 or x equals 4. Can't be both at the same time, I don't really think, but we get 2 answers. So if we know the y value, we might get more than one answer. So that's some function things that we're going to be looking at. Evaluating, finding domain and range, intercepts, those types of things. And our last concept for today is something called the difference quotient. And this is really set up to help prepare you for calculus. We use this quite a bit. And what I want you to see is this difference quotient really is just it's a slope, right? It's a slope function where one point is going to be x, f of x, right? That's an x value and a y value. And the other point is going to be x plus h, f of x plus h. So you'll see this when you get into calculus more often, but it's really just the slope formula, y2 minus y1 over x2 minus x1. And so what we're finding here is we're finding the slope of the function though. And since we've got a linear function, if you remember that linear functions, what's the slope? It's 7. So the slope of this function is always going to be 7. It's got a constant. We're going to see. So when we're done with this, we should get the answer just to be equal to 7. So we'll do this. But what do we need to do to use this difference quotient? We need to find f of x plus h. And we'll do it the same way we did the other one, is we'll take our function, we'll rewrite it as 7x minus 7. What goes in that input? Well, there's only one place. This becomes x plus h. And so this is, right, we distribute through. We're going to get 7x plus 7h minus 7. So that's for this part here. We'll go ahead and write that down. And it's all that. So 7x plus 7h minus 7. That's that part. We're going to subtract from that the entire function, f of x. Well, f of x is just this part. Nothing much to do except write it down. But be careful. A lot of times I've seen students will write this down without the parentheses, and then you don't end up distributing the negative sign. And of course, that causes an error, right? Because we need to distribute this. I guess before I go too far, though, don't forget the h here. Okay, and then we're going to combine like terms, simplify, all that kind of stuff. So this distributes through, so let's just rewrite it. 7x plus 7h minus 7 minus 7x, so I'm doing this part here, plus 7. And so notice what happens. You've got a plus 7x here and a minus 7x. Those become 0. You've got a negative 7 and a plus 7. Those become 0. Again, I get ahead of myself a little bit. Sometimes there's the h still. And so what we're left with is 7h over h, but h divided by h, let's go ahead and write that down. Becomes 1. 1 times 7 is 7. And that's it. Yeah, the slope is 1. That's really what the difference quotient gives us. It's the slope formula. For linear equations, we're going to see that. Now, later on, when you get into calculus, they'll often do this with quadratics or more, but this is the beginning part of calculus. Notice in the bottom what that would have been with our 2 points. It would have been x plus h minus x, and so the x's cancel out. All that's left is that h. That's why it doesn't really look like a slope formula at the beginning. But that's our lesson for Module 1. Now, the next thing for you to do is go ahead and complete the learning activities for Module 1. This is our homework. Seek assistance as needed for all the resources listed in the course, such as online tutoring, instructor's office hours, work with peers through the various discussion forums, but work through those learning activities as you need help. Reach out, get the help you need, and keep moving forward in this course.